So let's see what is the total probability theorem. Now, if I consider a case where there are two bags. So bag 1 here, let's say, has 4 red and 3 black balls. 4 red and 3 black balls. And there is another bag which contains 3 red, 3 red and 5 black balls. Okay, let's take different numbers over here. 3 red, instead of 3 red, I'll take 2 red and 5 black. So there are two bags over here which contain 4 red balls, 3 black balls, 2. So this is bag 1 and this is bag 2. Now here, as you can see, if I consider a case where I need to find a probability, okay, I'll write it for you. Bag 1 contains 4 red and 3 black balls. Bag 2 contains 2 red and 5 black balls. So can we say, if we want to find the probability, okay? But before that, if I have to find any probability, the question will be one ball is drawn at random. One ball is drawn at random from one of the bags. From one of the bags, find a probability. Find a probability that the ball is red. That the ball is red. So you have to find a probability that the ball is red. So let's see how to do this. If I consider a case over here where I'm considering B1 and B2 as these two events which are bags, and B1 contains 4 red, 2 red, 3 black and 5 black. But one ball is drawn at random from one of the bags. Now I have to select a bag. Okay. And what do we get? We get another event which says ball is red. So this is again a event R which I have defined over here. Okay. Now this event R can be split into two parts. This event R is split into two parts. First, when bag B1 is selected and a red ball occurs, bag B2 is selected and a red ball occurs. So I have split this red part into two red event, that is ball is red, into two parts. B1 is selected and the red, I get red. B2 is selected and I get red. So there are two things over here. So I can write it this way. Probability of getting a red ball is red marble is equal to red ball or red marble, whatever you call it, red ball is, first of all, I'll be selecting bag B1 and I get a red ball, or probability of I'll select bag 2 and I get a red ball. So again, I'll explain you. I have selected the bag 1 and then I'm getting a red ball. and I'm selecting back 2, I'm getting red ball. So B1 and getting a red ball, back 2 is selected and getting a red ball. So in all, this is the probability of getting a red ball. That is the probability that the ball is red. This is actually by using total probability theorem. So this is P of R we are calculating by using total probability theorem, because this is the total of the probabilities. So this is total probability theorem, and I can use P of B1 intersection R. I can split this now, that is by probability of B1 into probability of, since B1 intersection R I am taking B1, when I take the formula B1 will come below, R will P of R by B1, P of B2, and again B2 will come at the bottom, and R will come at the top, P of R by B2. So whenever I solve this, what I get here is P of B1, that is P of B1 means probability of selecting B1 and B2. The probability of selecting B1 and B2, since there are two bags only, it will be half, and probability of selecting B2 will also be half. Okay, so probability of selecting getting a red ball when B1 is selected, what is that? Probability of selecting red, that is probability of getting red when B1 is selected. Now how many red? There are 4. 4 out of what? 7. 4 out of 7. And probability of getting B2 are when 2 out of 7. 2 out of 7. So what do I get over here? That is 1 by 2 into 4 by 7 plus 1 by 2 into 2 by 7. So in all, if you calculate this, 4 plus 2 is 4 by 14 plus 2 by 14, that is 6 by 14, which is 2 threes are 2 sevens are, you get 3 by 7. This is the total probability that you are getting by using total probability theorem. Now let me come to the second possibility by using Bayes theorem. So the question will be similar, but the only thing that will change over here is bag 1 contains 4 red and 3 balls, bag 2 contains 3 black, red and 5 black balls. One ball is drawn at random and found to be red. So I'll change this part over here, and found to be red, and it is found to be red. One ball is drawn and found to be red. Find a probability that the ball drawn. Find a probability that the ball drawn is from the first bag. Is from the first bag. So as you can see over here, the question has been changed. The find a probability that the ball drawn is from the first bag. Okay. So now I'll be using Bayes theorem over here. I'll be using Bayes theorem. So let's see, how do I use Bayes theorem. Bayes theorem is used. Bayes theorem is used when there is a question of conditional probability. Now, if you like the question, you will find it conditional probability over here. So we use Bayes theorem, which is used to find the conditional probability. Okay. Now the question over here is, one ball is drawn at random. So one ball is drawn at random and is found to be red. So that means that the event red has already occurred. So can I say red has occurred means R has already occurred, and find the probability that the ball is drawn from the first bag. So P of B1 by R is what is asked to us. Okay, this is what is asked. So how do I start this? So if I start with P of B1 by R, P of B1 by R can be found this way. So P of B1 intersection R will be P of Okay. P of B1 upon R, if I look at P of B1 upon R, then R has to be, R becomes a sample space. R becomes a sample space, and in the numerator, you will get the intersection of B1 and R. This is what exactly is conditional probability. This is how we define a conditional probability. And so by using this conditional probability, I can also write P of B1 intersection R is P of R into P of B1 upon R. So I can write this by using conditional probability. Okay, P of R into P of B1 upon R. Okay. Now, I already have P of R upon B1 over here, P of R upon B1 and P of R upon B2 also over here. Okay. So I can use these two things over here. P of R by B1, P of R by B2 also I can use. So if I happen to use, if I want to use P of R by B1, P of R upon B1 will be, P of R by B1 will be, now B1 will become the sample space which will come in the denominator, and intersection of R, that is intersection B1, will come over here. And now I can also write it as P of R intersection B1 is equal to P of B1 into P of R upon B1. Now this is your equation 1 and this is your equation 2. If I say I can equate these two, and if I equate these two, can I say P of R into B1, P of R into B1. So when we equate these two, what we get is P of probability of B1 into probability of R upon B1 is equal to P of R into P of B1 upon R. So क्या मिलेगा अभी इससे, what will I get? अगर मैंने इसको rearrange किया तो I'll get P of, I want the value of P of B1 upon R. So P of B1 upon R यहाँ पर है P of B1 upon R. As you can see over here, P of B1 upon R का अगर मेरे को वैल्यू फाइंड करना है, then I'll put this on the one side. P of B1 upon R is equal to P of B1 into P of R by B1 upon P of R. So P of R मैंने already calculate करके रखा है, देखो यहाँ पर, that is by using total probability theorem. So this would be 3 by 7. And P of B1 into P of R by B1. P of B1 into P of R by B1. P of B1 is half. P of R by B1 is also calculated by using 4 by 7. पहले calculate किया था. So this is, if I cancel this, you will get 2 by 7, 7 cancel हो जाएगा यहाँ पर. You will get 2 upon 3 is the final answer. That is probability by Bayes theorem. Now this statement over here is called as Bayes theorem. ये जो मैंने अभी लिखा है यहाँ पर, यही Bayes theorem का part है. So we can use directly also this part. ये हम लोग directly भी use कर सकते हैं. बट इसको एक्चुअल में ये आया कैसे, ये डेमोन्स्ट्रेशन मैंने दिया है. तो मैंने प्रोबेबिलिटी, टोटल प्रोबेबिलिटी थ्योरम मैंने यहाँ पर यूज़ किया है डिनोमिनेटर में. तो ये पी ऑफ आर जो है वो ये पूरा आएगा इतना. ओके. सो अगर इसको लिखने का अलग तरीका मुझे चाहिए, तो पी ऑफ आर कैलकुलेट मैं यहाँ से करूँगा बाय यूजिंग टोटल प्रोबेबिलिटी थ्योरम. and the numerator is again calculated by this. So if I am applying Bayes theorem, then Bayes theorem will also include probability theorem. Okay, so it will include the sample space over here, or I can say the main event over here, that is P of R, which will be calculated by using total probability theorem, and the numerator again the values are given over here.